will discuss about unit number 3.3, that is site analysis in the solar PV installer course. The site analysis, that is an initial segment of urban and architectural process of designing. Initial means we have to begin with the site analysis itself. Okay, so it is purely dedicated to a study of historical, geographical, legal, climatic, and infrastructural background of a particular site. So only after analyzing the site, then only we can determine the feasibility of our solar PV system. Okay. PV arrays, they are attached on the rooftop, ground, or other structures, providing adequate solar access along with protection and support. So what are the requirements? So there should be adequate solar access, protection should be there for the PV arrays, support it should be there. The conditions on site and its result typically dictate an appropriate approach to use and indicate a location for mounting a system. So here are the tasks highlighted which are to be performed for site analysis. So first one is accessing the prerequisite for the solar panel installation. Prerequisite means prior. These requirements should be done. Only then we can install our solar panel. Then evaluating the location. We have to evaluate where we have to install the panel. Accessing the customer's requirement. So how much energy that is required by the customer. And last one is analyzing the suitable mounting structure. This is related to our previous units which we have seen studied. So the mounting structure, which one will be suitable for our specific site. So that's why we have to evaluate the location. Okay, then we have to analyze the suitable mounting structure. Okay, now coming to the first topic 3.3.1 under this unit. So accessing the prerequisite for installing solar panel. So before starting the installation of solar panel, it must be ensured that the requirements for the installation are available. So what are the requirements? So these are listed here. Tools and equipments needed for the installation, cables to be used in the installation, structure materials needed for mounting, adequate number of proper PV system components, then construction of the site where solar panels will be mounted. Okay, means site that is always not ready. Okay, we have to make it suitable so as to hold the structures which are supporting the solar PV system. Okay, so tools. Okay, tools we have discussed one by one. We are discussing now the requirements. So tools and equipments, the different type of tools, they should be made available. Cables, the type of cables which are needed as per our requirement. Just in the previous topic we have discussed it in detail about the cables, wires, and wiring of the whole system. The structure materials needed for mounting. I guess yes, that also we need. That should be ready only then we can mount our system. So other components which are needed for the solar PV system, they all should be in suitable supply, a suitable amount they should be available. Okay, the finest practice for solar energy system installation require a system optimization for solar energy production along with structural consideration. Okay, now the structural consideration we will be discussing here. So roof orientation and panel orientation. Yes, because in our initial units, starting units, we have studied in detail that the energy which is being produced by the solar panel, that depends on the amount of sunlight available, the inclination of our panel with the sun. Okay, that is why we are also using trackers to maximize energy production. So that is, it is always facing the sun. Our panel that is always facing the sun. Okay, so we need roof orientation and panel orientation. Both should be oriented as per the sun. Okay, they should follow the sun path in the sky. Okay, then the shadows. If the sun is moving and some object is creating a shadow over the panels, okay, that we should avoid. Okay, then next is roof slope. In case of the slope, we need mounting structure, different type of mounting structure. We can adjust, we need to adjust as per the roof slope. Then safety issues we have to consider. Shading, okay, some objects like trees, chimneys, vents, they can cast a shadow on our system, on the panel, and that will reduce the production. Okay, so we have to orient or install our panel at the site where the shadow won't be caused by these objects. Now, setback requirements. Now, what are the setback requirements here? Like the local building rules and regulations. Okay, normally in the societies also, buildings also, rules and regulations are meant, so they should be properly followed. Then issues with regard to installer and maintenance. Yes, installation and then maintenance. Both we have to consider. We have discussed them in our previous unit as well, with installation and maintenance. Then accessibility during an emergency. So is it accessible during an emergency situation? Okay, then pressure from wind load. This thing also we have to monitor. The pressure due to the wind. Okay, now another factor is type of roof. Now a flat, okay, or slope. We can install panels on both. Okay, but the supporting structures, that won't be the same in both of the cases. They may differ. So we have to select. Next, material, clay tile, asphaltic shingle or metal or shake, and placement and connection of panels. All of these types, these factors we have to consider for in the case of the roof. Then panel array layout. So layout like landscape portrait, how we have to connect it. Then how many panels are required? Okay, well, availability, that depends on the availability of the connection, number of panels we need to connect as per the voltage and current requirements. Okay, now trusses, rafters must be thoroughly inspected before installing a solar panel. Okay, an assembly. What is a truss? Basically, an assembly of pieces of wood connected along with steel plates forming a combined structural member, frame-like structure. Okay, that is a truss. We have to thoroughly inspect it because on that we have to place the solar energy system, the spacing, the condition, the size, that we have to check. Okay, so a truss resembles a common beam which supports load in an open space. Okay, what is the difference? The truss in tension resists force. Okay, unlike a beam. Beam is what it will become flexible when we apply some stress on that. So it is opposite in case of a truss. So the construction, like the truss or the rafter, they should be strong enough to hold the panel for long, like 20 to 25 years, because life of the solar panel, that is approximately 20 to 25 years. So our supporting structures, they should be strong enough to support it for this much long duration. Now, next topic is evaluating the location of installation. Okay, so whether installing of solar panel is successful, that totally depends on the location. Okay, other things we have calculated, but how the location, that is not suitable, or the way we have installed it, that is not efficient. The way I mean that the angle, some of the factors which we have just studied, inclination, shadows there, because shading, it comes under shading for most of the time. Then even though thoroughly designing our system, we will not be getting any output or any satisfactory output from the system. Because earthquake loads and wind load must be considered where applicable. Okay, so the solar panel must be installed in a way that the panels get sunlight for the maximum period. Okay, first requirement, the maximum availability of sunlight. It should not be like that sun is orienting and some other building has caused a shading on our structure. So that is then our purpose won't be solved of installing this panel. So next is the panel are kept out of any shade throughout the year. Okay, yes, so shading we have to avoid. So other obstruction like the trees, buildings, antennas. Okay, other factors like the dust, bird dropping, also on the surface of our solar panel, they are also undesirable. So regularly we have to clean it in that case. Okay, then the presence of water and snow in the installation should also be considered. That is also affecting the panels and the mounting structure. So if the sunlight falls perpendicularly on the panel, then maximum energy will be available. We have to consider these points. So the effect of snow that is shown here. Now, an example is given. The module should be facing true south in northern latitude. And on the opposite, it should face true north in southern latitude. Then maximum power will be available from our solar PV system. Okay, now next part is customers requirement. So in section 3.3.3, we are accessing the customer's requirement. The panel installer should inquire customers about the purpose of the installation. How much energy is required? What is the purpose? Why does the customer wants the solar PV system? So accessing their requirements and their preferences, based on that, the installer should suggest a type of PV system that will be suitable for that customer based on his requirements. So what are the factors which the customer should be informed? First one is the estimated cost for the installation. Next is the material required for installation. The next, any civil construction that must be undertaken for the installation of the panel so that the panel gets maximum solar energy. Then remove all factors that restrain the sunlight to reach solar unit. Like the trees are causing a shadow, then we need to trim the branches or some other items which can be removed or shifted. So we have to do that. So we have to inform the customer that we have to do that. Next is time required for the total process of installing the system. So all these things the installer should inform the customer. The type of load that will be attached to the PV system must also be accessed. Means we have to access the load. Okay, that we have already discussed in detail in our previous unit. That we have to begin from the load. We have to identify the load, then move in the reverse manner. Okay, so it will help to identify the requirements of installation. Okay, like a common example, the load, if it is DC, then we don't need an inverter. Okay, if it is AC, then we need an inverter. So direct, if we are using direct DC only, then the losses in the inverter that can be avoided. The loads that are energy efficient give economic efficiency to the system as well. So here in this table, some common AC and DC load, they are shown here. So DC load could be fluorescent light, 5 to 15 watt consumption, then stereo player about 40 watt, television 45 watt, refrigerator, ceiling fan. Okay, now similar devices are on the AC load as well. So how much watt is the rating, means how much power consumption is done by these type of loads, like the fluorescent light, 7 to 25 watt. Okay, here basically we are considering fluorescent light means that it will be CFL, 7 to 25 watt. Normally, fluorescent tube won't be of this much low voltage. It will be having more than 40 watt for the tube only, and then the choke. That is well. Okay, so CFL line lamp we can consider stereo player, then computer, television, refrigerator. So this one is a 100 watt, 100 liter refrigerator. If it is a larger capacity, then wattage will be more. So that is specified by the manufacturer of the refrigerator. Then cooler, microwave, power drill, okay, toaster, coffee maker, air conditioner. AC is more than 3,000 to 4,000 what they're consuming. Okay, 3.3.4 section that covers analyzing suitable mounting structures. Okay, so the location, civil construction, and other requirements decide the suitability of a mounting structure. Like the ground mount structure are most preferred for larger system. So what? So this is the specification. We can say large capacity system is very difficult to mount on the rooftop. Sufficient roof availability is also not there. On the ground, we need it. Okay, but on the other hand, it is acquiring space on the ground. Rooftop, they don't need any extra space there because they are using already available infrastructure. Building is already there, and on the roof, we are installing it. So it means that both of ground mounted or roof mounted, they both are having their own advantages and disadvantages. Now we select it as per the requirement. Large power we need, large capacity system we want to develop, then we will go for ground mount structure. Okay, so yes, for better space utilization, rooftop system, they are preferred. Because a PV array's layout may have a substantial effect on operating temperature and natural cooling. Okay, because we have seen that the output electricity production by a panel, so that is output that decreases with an increase in temperature. Okay, so 25 degrees Celsius, that is the standard test condition. After that, if the temperature increases, then electricity generated that will be less. It will start reducing. So cooling, that is needed. Normal air cooling, that is also suitable. So there should be space between the mounting structure or the roof and the panel. There should be space. We are considering passive cooling of the module. This is one type of passive cooling by air, natural air. So there are chances of horizontal layout having some benefit over the vertical layout. Okay, then a landscape unit allows more uniform cooling as air tends to be under a module for a shorter time frame before it escapes. Next, a mounting placed 3 inches atop a roof is considered coolest. Means at least 3 inches space we have to provide between the roof and the PV array for the cooling, natural air cooling. Mounting PV arrays on rooftop areas are restricted by following factors. So consider these factors. The necessary space for service and installation. Okay, this one thing. Fire code, ventilation and pathway. Then setback by wind load. Then required space for other tools and equipments. Because these we cannot compromise. We have to give space for these other auxiliary components as well. So now coming to sloped roof. They need fall important protection system or personal fall arrest system for maintenance worker and installation because they are on a slope. So protection for the installer, for the maintenance worker, that is also needed. So photovoltaic arrays may be roof mounted on a sloping or flat roof. Then ground freestanding. So both type. So suitability of installation of a PV systems, roof construction should be ensured. Okay, the figure here shown here that indicates the major aspects to evaluate while considering the site survey for a PV array. So first one, building type and roof design. First one, which type of roof is that and which type of building that is there. Then roof dimension, slope and orientation. That also we have to observe, okay, or evaluate. Then roof surface type, condition and structural support. After that, fall protection methods required. And then access for installation and maintenance. Because installation, after installation, maintenance is also a factor. Regular cleaning, that is also needed. So cleaning can be okay, it could be automatic as well. But we have to make provision that for maintenance purpose, we can assess our system, the panels easily. Now here in this next figure, the inspection point for the site survey for ground mounted PV array, they are indicated like zoning and restrictions on land use. Okay, then next is type of soil and ground cover array. After that, drainage, field zone and water table. Okay, next is requirement for array foundation. The next, requirement for security and fencing. And last is access for equipment, vehicle and maintenance. Okay, so these all factors we have to consider during the site